Hello, I'm Mr. McBrien. This is TEJ20, Turing 4, Introduction to Graphics. Yesterday we talked about if-then, and we talked about loops and decision making. Today we're going to talk about aesthetics. So, it's been a long time really since we could get away with writing software that had purely text-based interaction with the user. We have come to expect something much more attractive from modern software, and in fact there are whole careers around the idea of the visual aspects of software and designing them in an attractive manner. Turing contains some tools. I wouldn't call it the most sophisticated language in the world around those aspects, but it contains a series of tools that we can use to make the software we design look and feel more attractive. So today we're going to do the first aspect of this. There's certainly much more that we can go into beyond this. So let's start with the idea of drawing objects. The details of how to create geometric shapes and these kinds of things are really beyond the scope of a PowerPoint presentation. I think it's more appropriate for you to look at the online help in Turing, and I encourage you to just go in and experiment. So you can pop open the online help and play around with that, and you can see some of the objects that you're able to use and some of the options associated with these. So if you go ahead and open up the online help, you can pause it, play around, and start to place some objects on the screen by writing a little bit of code. So just write a few subroutines, pause the movie, and then come back after you've experimented with this and come up with maybe some questions that you hope we can answer, and hopefully I'll have anticipated at least some of these. Okay, so welcome back. Now, if you played with simply drawing objects, one of the first things you probably wound up asking about was, well, how do I place them in specific locations? So Turing, of course, will allow you to put them wherever you want on the screen, and the concept itself is really pretty simple. The bottom left is the origin, 0, 0. The top right is max x, max y. And any other location is just in a range between these. Now, so that raises the question, of course, what are the units of those numbers? And the answer is pixels, and that means that the dimensions themselves depend on the resolution of the screen. And this is a blessing and a curse, so we should probably elaborate on this a little bit. If you want to be able to predict what's going to happen in your programs, you need to actually understand how big your user's screen is. Screen graphics they create a challenge in Turing around displaying given objects. So one way that we can sort of make our displays more predictable, when we know that the user may have chosen a resolution that we're not anticipating, one way we can make them work is we define the screen in terms of pixels, and that's locked in regardless of what resolution setting the user chooses. And so we can do this. We can set the screen to a number of pixels, both in the x and y dimension. So we can create our application and lock it down in terms of size. And this is only some part of a solution when you think about it. It's one approach to this problem, and it's only somewhat consistent with modern Windows philosophy. But I'd suggest you take this approach for now, unless there's some logistical issue with doing so. I'd suggest you simply lock down your screen size and let the user deal with that situation as appropriate. And the only catch would be if the user has a screen that's too small. If the user has a very large screen, it'll mean you'll only occupy part of his or her screen. Well, that's okay. That's not such a big deal. Okay, so feel free to play with that command if you wish, or you can simply incorporate it in some of the code we're going to do next in our activity. So we can use the viewSet command that we talked about in the last slides to set the dimensions of our screen. And once we've done this, I'd encourage you to just simply use the commands to create rectangles and arrange them as an array on your screen. In fact, I actually use this to generate a match game for cards. But in your case, you're just doing this as an exercise to get used to the idea of positioning objects on a screen. So lay them out in a regular fashion. And for practice, you may wish to create a loop instead of creating 25 lines of code. That's totally up to you at this stage. And here's something like what your output would look like. I chose purple for my rectangles. If you find that easy, very simple, why don't you try working out a way to make every color of the rectangles be different? And again, much more interesting to make this part of a loop. Okay, fonts. So we can do all kinds of different things with text, of course. We can use colors, fonts, sizing to communicate appropriately with the user. When you're doing this, go ahead and mess around with some of that. You can modify some of your existing programs to change up the way those appear as you're interacting with the user. Another aspect of your programs. What about the background? So you can stick with plain white if you want to, but this doesn't give it a very natural feel, and it may be entirely inconsistent with what you want to achieve in your software. So why not set the background color? You can do this very easily. There are a couple of commands that can do it. One is the draw fill box command, and that sets the background color once. And the other is something that does it for the duration of your program. So the color of the background command will set the color throughout the entire session. And so if you ever do the clear screen command, which you'll likely need in your programs, the background will remain that color, as opposed to the draw fill box, which when you clear the screen, that'll disappear. So those are two useful commands that you'll likely wind up needing at some point for your application. All right. So you may want to incorporate these commands, try them out. You want to try them out now for sure. You may want to incorporate them with your rectangle application and make this part of your submission. So you can try a temporary background change and try a permanent background change, and incorporate a clear screen command at some point as well if you like. Go ahead and play around with that. So what have we covered today? We covered the idea that it will be an expectation of any software that you create that it look good. And we've talked about some of the limitations of Turing code for displays, and some of the powerful things that you can use as well. So I can say that when your application is evaluated, one of the things that I will do is experiment with changing my screen resolution in order to make sure that your code still works and that the user interaction with the software is still good, even when resolution changes. So you might want to put this in as part of your testing for your eventual application. So for your homework, Be sure and upload the test code that you've created over this work. And you might want to try playing around with, do a few experiments with Windows resolution to see the results from any of the graphical programs you've created so far. Try some experiments and see what happens, and this may help you in your design phase for your application. So that's all for today. Thanks very much, and have a great day.